Welcome to part 3 of the Dueling AI series. Today we're going to be working on adding some actual gameplay functionality to the Pong game, but a bit of housekeeping first. So if you had any trouble with the last video, something I've always at the end of the videos published the full repository for anyone who had trouble along the way and wants to look at it. What I'm going to do this time is every single time I release a video, I'm going to commit the code from that video to the repository and tag it with the video part. So if you just finished part 2 and the code isn't quite doing what you expected and you'd like to go reference my part 2 code, you can come to GitHub. I'll post the link in the video description. And you can click the part 2 tab or tag, and that is going to take you to the latest code as of part 2 in the video. You can see that's a commit from 10 hours ago. I was working on it last night. So same with this one. If you get to the end of this video and there are things you feel like you've missed, you'll find a part 3 out there at that point, and you can go and look up the code as of the end of the part 3 video. All right, with that out of the way, let's take a look at what functionality we have right now, just as a quick refresher. So where we left things, we have a Pong game, or we have a screen with a score on it. It's not really a game yet. And we had it to the point where you could do J and K and feed in player 1 actions, or E and F on the left hand, and it feeds in player 2 actions. So that was working. And by the way, you do have to have this selected. If you click on your editor and try to hit EF, it's not going to do anything. That's what got me just a minute ago. So we've got that up and running. Let's go to, that split my windows not the way I wanted. Let's try again. All right, we've got our game.py, and the next thing that we're going to do here is go ahead and actually start working on some of our assets, which are actually not going to be in game.py. They're going to be in assets.py. So let's just create an assets.py. And that's going to hold things like our paddle, our ball, and that should be it. We don't have any other game assets. So let's go ahead and we're going to do a few imports. We're going to say from random import. No, that's not what I wanted. From random import random. We're going to import Pygame. We're going to import NumPy as NP. We'll be using NumPy later. And that should be it. Actually, instead of this, let's just do import random. Okay. And then the two classes we need are class paddle. Throw a pass in there, and then we need class ball. All right, and we're going to implement class paddle first. So the core object that you end up working with most of the time in Pygame is a rect or rectangle. So that rectangle needs an X coordinate, a Y coordinate, a width, and a height. So what we're going to do is we'll do our def init, and we're just going to do X, Y. We'll go ahead and pass in a player color. We need to give it window height because this will help us figure out where the paddle's supposed to be. And then we'll do width is equal to 20 and height is equal to 120. This is probably a good place too, where if you are using a smaller screen, you want to be looking at what your actual sizing should be. All right, we're going to go ahead and hop down to here and do self.x is equal to x, self.y is equal to y. And actually, let me talk for a moment when I say sizing. When I launch this game, it shows up in a reasonable size for my screen. If you launch it and it's completely off your screen, take a few minutes, go back to game.py and figure out the right game size for your display, whatever that is, the right size in pixels. There are also tricks you can use to do like a virtual screen in Pygame to adjust it without adjusting these. Not going to mess with that right now. That's not really the point of this series, is getting deep into Pygame. But yeah, take a minute now and make sure that this window is the size that you want it to be, because everything else is going to be relative to it. All right. So width 20, height 120. We're going to do self x, y, x, self y, y. And then we'll do self.height is equal to height. Just setting all our params here. And I think somewhere along the line I got, there we go. That's better. Self.width is equal to width. And now we declare our rectangle for the paddle. So self.rect is equal to pygame.rect x, y, self.width, and self.height. Okay. We're also going to declare a speed. Our speed is going to be self.speed is 14. Again, 14 pixels. Self.paddle color is going to be player color. And self.window height is equal to window height. It's another one, since the speed is in pixels. If you go for a smaller size, you need to reduce speed. All right. Next up, we need to set up a draw method for this paddle. So def draw self, and we're going to pass in screen. It'll need a screen to draw on. And then this is going to be pygame.draw.rect screen self.paddle color. And then in parentheses, we're going to do self.rect.x, self.rect.y, self.width, and self.height. Okay. Pretty simple. And obviously you could put this logic outside of the class. For games like this, I prefer to have the move and draw logic where possible inside the asset class itself. All right, now we're going to need def move self direction. And we're just going to throw in an assert here that 0 is less than or equal to direction and less than or equal to 3. Basically making sure that what we're passing in, and actually we don't even need an equal there, we just need less than 3. Basically making sure that anything we're passing in is between 0 and 2. And let's add just a note here. Direction 0 is no action. All right. If direction is 0, we just want to return. We don't want to do anything. Elif direction is 1, then new y is equal to self.y minus self.speed. Elif direction is equal to 2, then new y is equal to self.y minus plus. Here we want to do plus self.speed. Want to go up on the 2's. If 0 is less than or equal to new y. So what we need to do here is we basically just want to make sure that we are inside the world bounds. We don't want our paddle to just sail off into the distance. We want it to, stay on the board. So we're going to say if new y, we're basically saying making sure that it's greater than 0 and that it's less than or equal to the window height. So self.window height minus self.height. So basically we need to subtract the height of the paddle from the window height, and then that's our upper bound. So self.y is equal to new y. And then we set a self.rect.top left is self.x and self.y. All right. And we're not calling draw in here because draw will be called by the external loop. So these two are separate. We will in the main loop we'll call move, and then we'll call draw. All right. And it's complaining about new x and new y. Let's see why. Where should I have had that? All right, I went and took a look, and it was just my editor config. It was complaining about this being potentially unbound, and I really don't care. Another way to solve this would have been to throw it up here as a blank variable or as a 0. But if it's 0, we're returning. We're checking for asserts up here for direction. I'm pretty confident that this code is not going to result in an unbound new y. All right, so we're good there. That is the end of our paddle class. Let's go ahead and go back to the game.py, and we're going to implement our paddle. And give me just a moment to get GamePy pulled up on my other screen. All right, so we're going to set our paddle in the self.reset method. And we're doing it here so that it will get reset to the original position anytime the game resets. We want the paddles to go back to right where they're supposed to be. So player 1, self.player1 paddle is going to be equal, we need to go import paddle from assets, import, we'll just import star. We'll need the other things later. Okay, so paddle, and x is going to be self.window width minus 2 times self.window width divided by 64. Y is equal to self.window height hang on, divided by 2 minus self.paddle height divided by 2. Player color is equal to self.player1 color. And height is going to be self.paddle height, things that we've set statically. Width is equal to self.paddle width. And window height is going to be equal to self.window height. And what this should do is this should put player 1 paddle right in the middle of the left side of the screen. I believe we put player 1 on the left. We're about to find out. This is the downside of of writing code and then coming back 2.5 months ago or later and talking about it. So let's go ahead and throw an update in our step function that's going to actually display these things, because we're going to need that. All right, so right here, we're going to do self.player1 paddle.move, and it'll be whatever player one's action is. And then we will do, we actually need self.fill background down here. So we're going to move player one's paddle. We're going to fill the background. And then we're going to say self.player1 paddle.draw. And we'll pass in screen is equal to self.screen. Okay, let's see what happens. Hey, we get a crash. Okay, not supported between instances of int and none type. Okay, that's all right. We're just going to default to 0. Later on in the code base, we have enough set up to make sure this is always valid. All right, we have our paddle here, but it's not doing anything. We're not getting any movement. And I don't think we're getting any movement because when we call step, we are not passing it anything. So let's go ahead and come up here to down here to our game loop. And in our game loop, we need to call player one action is equal to player one action, and player two action is equal to player two action. And now you should be able to hit J and K and have a little moving paddle. So we have the start of some functional game mechanics, which is a really cool place to be. All right, let's go ahead and close that out. And we're going to go and set up the other paddle. So we can basically just copy all this and come down and paste it. And we're going to make it player two paddle. And then we just need to make a few small edits here. So it's still going to be, instead of self.window width -2, so this is the part that basically pushes it over to the right. So self window width -2 is basically saying, hey, we're gonna shove you all the way over to the right hand side of the screen. We don't need that anymore. So now we can just do self window width divided by 64. That's going to give us the appropriate level of distance from the side of the screen. And then we can do self window height divided by 2 minus self dot paddle height. And that's still going to place us right in the middle. And then we'll do player 2 color. And then everything else here should be able to stay the same. Now let's go back down to our step method. And we're just going to copy this and have player 2 paddle move with player 2 action. And we'll copy this and have player 2 paddle.draw. And at this point, we should be able to run the code. And we now have 2 paddles. And you can control one of them with E and F and the other with J and K, which is a really cool place to be. So now we have most of our game. We've got some paddles we can control. Let's go ahead and implement a ball. All right, so this is going to be back in assets.py. And if we come down to our class ball, we're going to do something very similar. So def init self dot, well, not self yet, window height, window width, player 1 paddle, player 2 paddle, and then our ball width is going to be 10, and height is going to be 10. All right, and that's exactly what we expect. So as usual, we're going to go through and do self.height is equal to height, self.width is equal to width, self.window height is equal to window height, self.window width is equal to window width, self.player 1 paddle. So this was something that I struggled with on the decision making side, where to actually put the collision detection, and where I landed was putting it in the ball. So basically, we're going to pass player 1 and player 2 paddles into the ball move method, and we'll do collision detection in the ball's move method to see if it has if it's hit one of the paddles. That's the way we're going to handle this. So player 1 paddle is equal to player 1 paddle. Self.player 2 paddle is equal to player 2 paddle. Self.ball color will be 255, 255, 255. And self.max speed is going to be equal to 30. All right. And we're going to need this later, but let's do self.last serve left is equal to random dot choice true false. All right, this is probably the first place where we're going to talk about something that's actually RL related. So one of the things that I noticed really early on was doing self-play was seeing consistently higher scores for one side than I did the other. And it actually really threw off training. And there was a lot that went into that. But one of the big smoking gun issues was that it always served to one side. So I had it by default, hadn't thought about it. It just always fired off to the right, which meant that the player on the right was being constantly peppered with, shots from the ball, and the player on the left only got served a ball when the player on the right actually hit it. So what we're going to be doing is randomizing the direction that the ball comes from. That's another thing that maybe wouldn't matter. It would matter for fairness if you were playing against a computerized component, but it wouldn't really matter for learning. If the agent was always served the ball, it doesn't care. It's going to learn how to hit the ball. If the ball goes in the other direction all the time, if it's always not served the ball, then it'll just learn how to respond to another player hitting the ball at it. But if you are doing self-play, then having, one side of your agent constantly served a ball and the other side not is a little bit of an issue. All right. And then finally, we're going to call self.spawn, and we don't have a spawn method yet, but we're going to create one. So let's go ahead and do def spawn, pass in self. All right, so self.x is equal to self.window width divided by 2, and self.y is equal to self.window height divided by 2. So we're going to drop the ball right in the middle of the screen. Speed is going to be random.choice from 10, 12, and 14 pixels. And that's how much it's going to move every step. And the reason I made it random is, frankly, just to make the game more fun. You can have one static speed. I find that firing it off at various random speeds to make it a little more interesting. All right. And then self.lastServeLeft equals not self.lastServeLeft. This is basically going to flip last serve left every single spawn. And then self.vx, so this is going to be our x velocity, is equal to the negative of speed if self.lastServeLeft else speed. All right, and what we're basically doing here is we're saying our x velocity is going to flip every time. That's what these two lines give us. In fact, let's add a comment. Flip x velocity every spawn. So every time we spawn, we flip. Self.vy will be a random.choice between -6, -4, -2, 2, 4, 6. So basically, this is going to make it fire off at various angles throughout the game. And we could have done something like this, random.choice, for just direction or, X speed. We could have done, negative 14, -12, -10, and that would probably work fine. The reason I'm hard coding this a little bit better is, or a little bit more consistently, is during training, I was trying to I was running into problems with things that were throwing the balance off, and I was trying to just be really, really consistent with how often I served each side of the ball. You could do just a straight random.choice like this with negatives included, and it would probably be fine. But the implementation above is just a little bit more robust. All right, so we're going to do self.rect. Again, everything's a rectangle. Pygame.rect, self.x, self.y, self.width, and self.height. All right, we now have our ball spawn. The next thing this will be a little helper method. So get step increment is, in fact, let me see if I actually used that helper method. Yes, I did. All right. So def get step increment self velocity. If vel is greater than 0, return 1, else return -1. All right. This will make sense in a minute. So our next and final method here is our move method. And this is going to be a little bit, we need move and we need draw. So let's go ahead and work on, let's do draw first. Draw is going to be super easy. So def draw. And actually, you know what? If you have been following along, pause and go implement your own draw method based on what you saw in the paddle. All right, I'm going to continue. For those of you who tried, hopefully it worked for you. So self screen, pygame.draw.rect, screen, self.ballColor, self.rect.x, self.rect.y, self.width, and self.height. All right, we now have our draw method. And I'll give myself another space there. All right. Next, we are going to define our move. And this one is going to be kind of complex because it includes collision detection. So we're going to do def move self. And then just like we've done in other places, we're going to do new x is equal to self.x. New y is equal to self.y. And we're basically just going to be editing those new y variables as we go. And then at the end, we will, set self x and self y to them. So we'll do x step is equal to self.get step increment, self.vx, and y step is equal to self.get step increment, self.vy. And let's talk about something we're going to be doing here in y. And this is going to be hard to visualize, but you can do a simple implementation of movement in Pygame is just to add speed, whatever the speed variable is, to your moving object every single step. So, and it actually looks fine visually most of the time, because if you're moving by 10 pixels, it's basically just going to, inch along at 10 pixels, whatever that, whatever that increment is until it hits the paddle. The problem is when you get into collision detection and scoring detection, you need to know the exact pixel when something came into contact. You can't have your ball go 5 pixels into the paddle. And that's especially important when you get to scoring. If a score is when the ball is completely off the screen versus a score is when the ball just touched. You also get into some weird stuff where, like, if you're checking for collision, but you only check midway into the paddle, the ball can get stuck and just like stick to the paddle because you've, tried to reverse direction. There's lots of bad stuff that can happen if you are not fine-grained enough with your collision detection. So what we're doing here with these X step and Y step is, even if velocity is that we are going to move by 10 pixels or 14 pixels or wherever we land at, we want to take that in single increments of 1 pixel. And those single increments need to be in the right direction. So that's why we have this get step increment function to go ahead and say, hey, if velocity is positive, then I want a 1. I want 1 to be my step increment. If velocity is negative, then I want -1 to be my step increment. And then we're going to iterate towards whatever the final position was supposed to be. And if we hit a collision anywhere along the line, we're going to stop and report that collision. All right. We are going to do new rect is equal to none. We're not going to declare one yet. We are going to do, let me check something real quick. All right. We're going to need an early collision detected. And we're going to set that to false in the beginning. And then we'll do if self.rect.collide rect self.player1 paddle, or self.rect.collide rect self.player2 paddle. That's getting a bit long. Let me just drop that down. Let's see. Then early collision detected equals true. And what we're doing here is we're trying to figure out if it's already collided, because again, we want to avoid that stuck to the paddle problem. This is something I did a lot of troubleshooting on, where I'd be playing, and then if it hit the paddle the wrong way, it would stick to the paddle, and then sit there cycling with the ball stuck, which is really not ideal. So here we're going to do for I in range, and we want the absolute value in integer of self.vy. New y is equal to new y plus y step. So again, this is us taking small steps. If not, early collision detected. And then in our inner if here, we're going to say if not 0 is less than or equal to new y is less than or equal to self.windowHeight minus self.height. So again, we're basically just saying if it's not already collided and it's not inside the, if it's not out of the world bounds, then we want to say self.vy is equal to np.clip, because we want to stay inside of a maximum speed. Self.vy times -1. Let's see. Plus self.random choice. Not self.random choice, random.choice. -1, 1. And we want to clip that to the negative of self.max speed and self.max speed. And then we want to break. So let's talk about what we just did, because that was a whole bunch of numbers here. So what we're basically saying, so no early collision was detected, but then we're saying if not inside the world. So what inside of the world from a y perspective. So remember, y is up and down. So this is saying if you collided with the top or the bottom of the window, then we're going to set y velocity to -1, and we're going to add, randomly add either -1 or +1. So we're going to add a little bit of randomness to that bounce. And when I say to that bounce, let's show what that would look like a little bit. So what this logic implements is if the ball is headed up, so, you know, in this scenario, our y velocity is, let's say 5. So we're heading up, we've got a 5y velocity, we hit the top. Well, we now need a -5 velocity. So we just applied a negative and then it bounces back down. We don't need to change x. X is still moving to the right here. We just need to change y. So we hit top, we bounce back down, we keep going. Again, with a little bit of randomness, just to mimic what would really happen. Again, if you think about it like, you know, you're playing pool, you hit a ball, it hits the side of that pool table, it's not bouncing perfectly. It's going to randomly, or at least randomly as far as you can tell, wobble just a little bit. It's going to move a little more than it would if this was a perfect, you know, equation. So that's what we're trying to model here, is a tiny bit of randomness in the process. So next up, we are going to come down here and say, actually, let me get a little bit of extra room there. I think that helps. Actually, no, it doesn't. It makes it harder for me to see. I'm blowing the text up drastically to make this visible for YouTube. It is clownishly large on my screen though. So let's go ahead and say if, actually no, we need to go ahead and do new rect is equal to pygame.rect. So now that we know we're not colliding with the top or the bottom, we can go ahead and do pygame.rect new x, new y, and self.width, and self.height. And then if new rect dot collide rect self.player1 paddle, or new rect dot collide rect self.player2 paddle. All right, I'm going to do another, bringing this down. Then we're going to grab self.vy is np.clip self.vy plus random.choice again, -1, 1, and self.max speed, and we want the negative of self.max speed, and self.max speed, and then break. Okay, so now we just handled some of the paddle collision. So for range, so basically we're slowly iterating here on the y dimension, and that is a point to remember. So everything we just did here was a for loop around the y collision. So now we're going to go and work on the x collision. So for I in range, abs int self.vx new x is equal to new x plus x step. If not early collision detected, then new rect is equal to pygame.rect new x, new y, self.width, self.height. Okay. And we don't have to do a whole bunch of logic for early collision because we already did that. So now we can say if new rect dot collide rect self.player1 paddle, or new rect dot collide rect self.player2 paddle. We'll do another. You know what? I would rather have that line up. Then we want to do self.vx is equal to np.clip self.vx plus x step times -1. And we want that to be negative inside self.max speed and self.max speed. And what we're doing here is we are both invert the ball direction and speed up the ball slightly. So that's actually going to, the gameplay dynamics that we're trying to get here are if the paddle hits the ball, if the ball hits the paddle while it's going in an X direction, it should actually speed the ball up a little bit. And that's another making the game more interesting kind of thing. At some point, the ball will, if it continues to move at its original relatively slow speed, it becomes an uninteresting game. You hit the point where it's going to score, it's going to hit the ball perfectly every single time. It's going to bounce back and forth. By adding a speed up component, what we're basically landing at is as the game goes on, the ball is going to get increasingly faster, and then eventually, hopefully, one side will score, whoever misses it first. So this is to model those dynamics. So we want to say self.vy is equal to np.clip, and then self.vy plus random.choice, -1, 1, and then again, we want to clip that inside self.maxSpeed and negative self.maxSpeed and self.maxSpeed, and then we want to break because we've collided. All right, and then now that we're done with our for loops here, if we've made it down here, we should be in a place where self.x can be new x, self.y can be new y, and self.rect can now be pygame.rect new x, new y, self.width, self.height. Okay. Assuming no typos, this should now be complete. So let's go back to our game.py and implement. All right, and I'm taking a moment to remember where I put that code. All right, this is going to be in reset. So we're going to go to self, we're going to declare a self.ball is equal to ball. And then we'll pass in window height as self.window height, window width as self.window width. Height in this case will be 20. Width is equal to 20. And we'll pass in player1 paddle equals self.player1 paddle. And player2 paddle is equal to self.player2 paddle. Okay. Now, if we get down into our step method, this is where we've played out our, we've done our player1 paddle move, fill background, player2 paddle, draw. Now we need to do self.ball.move and self.ball.draw. Screen is equal to self.screen. Okay. Let's see if we've missed anything. Okay, we now have a ball, but as we can see, it flew off the end of the screen there, and is no more. So let's close this out, and we actually need to make a couple. Let's go ahead and make a structural change that's going to come in later. So one of the things that we're going to need to do is be able to repeat an action. So something, if you pass in an action of 1, you want it to repeat a certain number of times. And that's mostly, it's perfectly fine to not do that on a human playable game. But when we get to the AI playable section, you want your AI to get somewhat notably different observations each time. You don't want a replay buffer that's completely full of things that look identical because only one pixel has had time to change between frames. So adding an action repeat and allowing it to say, hey, move up, and then have it move up 3 or 4, cycles. Again, keeping in mind, we're talking about a few frames of movement, not shooting the paddle all the way up to the top, just giving it something closer to a human, reaction speed requirement. that frame step is going, or frame skip is what that's normally called. The way we're going to implement that is we're going to say underscore step. So we're going to change our step method to an underscore step method. And that's basically going to make this an internal method. And then we're going to do our external step method, which will also have self player 1 action, player 2 action equals 0. And then what this external step is going to do is it's going to say for I in range, self dot step repeat, self dot step player 1 action equals player 1 action, and player 2 action equals player 2 action. All right, before we try to fix anything else with the ball, let's just go ahead and make sure that the game still works. And it does. Okay, we now have our step repeat is functional and working. So the reason I went ahead and fixed this is we are going to add the ball spawn capability to this outer step method. So here we're going to say that ball center, and this is important, we want to count a score only when the ball center is over, not when the ball left, because by default the X and Y are, if I recall correctly, the top left-hand side of the object, the ball. So we want to make sure that only when the ball center crosses off the screen do we count a score. And the reason we want to do that is because if you don't, you end up with a case where the ball is completely gone off the screen on the right, or isn't gone at all off the left, and the score is still counted. And that gives your agent a very inconsistent goal. This is something that is, as you're designing games that are meant to be played by AIs, a human can look at the whole game and understand, like, we don't even notice the difference between scoring when the ball is, 90% over the finish line versus when it's just touched the finish line. Like, we understand intuitively that the ball made it, we scored. You don't have to tell a person that that's what happened. And in fact, because these things are moving fast, we don't even notice. Your AI is literally looking at the frame that a reward was returned on. So if that frame shows that the ball is still in the picture, that is a very different view than showing that there's no ball on the screen. It's not going to understand that no ball on the screen means it just scored. So the logic you use here is important. So self.ball.x plus self.ball.width divided by 2. All right, so we're going to say if ball center is less than 0, then self.player1 score plus equals 1 player 1 reward. And in fact, let's go ahead and declare these up here. So we're going to do player 1 reward is equal to 0. Player 2 reward is equal to 0. And then we'll need these later. So let's just go ahead and do done is false. Info will be an empty dictionary, and truncated is false. All right, there we go. So we want player 1 reward plus equals 1. Player 2 reward minus equals 1, because if player 1 scored, that means player 2 failed. and we want self.ball.spawn. And then down here, we want to say elif ball center is greater than self.window_width. Self.player2score will be plus equals 1. And player2reward will be minus equals 1. And player1reward will be, actually, no, hang on. Player1reward will be minus equals 1. And player2reward will be plus equals 1. And then we will again self.ball.spawn. Okay. Okay, so you'll notice, and by the way, if it's not obvious, this is me playing both sides. So at this point, you are 100% human controlled. And what you'll notice is that every time it goes over, we now get a successful score method. So we're basically at a point where a human can successfully play either side of the game, which is a really good spot to be. Now, we don't have any kind of, end game logic in here. The way this is set up right now, I'm just going to park that off to the side. It'll basically sit here and score forever. There's nothing stopping it from just continuing to rack up points, and the game will never end. There are also no computerized opponents, so nothing for us to play against. And obviously, we're not at a point where we can quite link this in and start doing reinforcement learning on it. So this has been, I think we're at 57 minutes of video. So I'm going to go ahead and end this one here. In the next video, we will go ahead and start working on an end game system so that it doesn't just sit here and play forever. And we will build out our bot players that will later use as a scoring mechanism to see how well our AI is doing. So with that, I'll see you in the next video.